Okay, I think this is actually working. We'll see. So 2014 free response question. All right, 2014 free response question, part A. That's obviously me making sounds with my mouth. Okay, so we've got the two curves. Again, when I start this, I'm going to always point out to myself which is which. So I'm going to, oh gosh, I don't want that, but whatever. I'm going to point out to myself that this is r equals 3. And this, that goes like this, and here, is r equals 3 minus 2 sine 2 theta. So to keep track of what's what. So how do I find this area? Well, I'm going blah, 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 blah. Okay, so this is going from 0 to pi. So I have two different curves happening. I have two different areas I have to consider. I have the area inside of this, which is if I go out from 0 to here, it starts accumulating all of this. And then a different section altogether from from pi over 2 all the way to pi. I've got the area inside of this. So two different sections going on will give me the integral from 0 to pi over 2 of 1/2 r squared, and that r is going to be the 3 minus 2 sine 2 theta. And then I'm going to add on the integral of pi over 2 to pi of 1/2 3 squared. That's basically it. There's not a whole lot other stuff that you can do with this because I don't have two identical parts that I can find the area of and double my answer. So that's basically it. You can go through and do the answer for this. I feel like I should do it for you so that you can see the work. It does say find the area of R. Yes, this is technically a calculator question, but I do want you to be able to go through this without the calculator. So why don't I go through this one? Let me see how much space I have here. Okay, I can move down if I need to. So let's go through and get the answer to this. All right, so I'm going to have the integral of, I'm going to FOIL this. I'm going to bring the 1/2 out. And I'm going to have 9 minus 12 sine theta plus 4 sine squared theta. And for this, I'm going to bring the 1/2 out. Actually, it doesn't really matter, whatever. And I'm going to have just 9 d theta. Erase this. I'm going to end up putting both of these parts together, but I'll just do them separately. Get this to go away. There we go. Okay, so this is going to become, I'm going to have to replace this with the identity. So I'm going to have, I'm going to put the 1/2 in and just not have all this all over the place. So I'm going to have 9/2 minus 6 sine theta plus 2 times 1/2. I know that this is going to be cosine 2 theta over 2. And again, I always have to go look up. So like I go Google power reducing identities, or I have it written on my notes, but I don't right now. So sine squared reduces to 1 minus. Okay, so let's take that. And let's see if I can get down to this line. I'm going to have the integral of, I'm going to have 4.5 here plus 1 here when I distribute this 2. So let me just go ahead and I'm going to cancel 2, 2, and 2. So 4/2 minus 1, 4.5 minus 1 is 3.5. So this is going to be 7/2 minus 6 sine theta minus cosine 2 theta. So now let's integrate. I'm going to have 7/2 theta plus 6 cosine theta minus sine 2 theta divided by 2. This is being evaluated from 0 to pi over 2. I'm always so happy when it's not pi over 6 or pi over 3. It's so much easier. So I'm going to plug pi over 2 in. So this is going to become 7 pi over 4 plus, plug pi over 2 in for this one, we're going to get 0, minus, plug pi over 2 in for this, pi over 2 plugged in here will give me the sine of pi, which is also 0. So that just becomes 0. Minus, now let's plug 0 in. So this is going to be 0. Plus, plug 0 in for this, we're going to get 6. Minus, plug 0 in for this, we're going to get 0. So this part should be 7 pi over 4 minus 6. That's half of it. Let's go get the other half. Let's go back up and not forget to integrate this part. So the integral of this is going to be 9 theta. We are times a half, so we're over 2. From pi over 2 to pi. So both of those get plugged in. So we have 9 pi over 2 minus 9 pi over 4. So this is going to be a 9 pi over 2 minus 9 pi over 4. Put that all together. I really don't want to, but we will. Let's change this to a 4 and change this to an 18 so we have the same denominator. So 7 plus 18 is 25. 25 minus 9 is 16. So we have 16 pi over 4, which would be 4 pi minus 6. That's what I get as my final answer. Hopefully I'm right. Who knows? It's really a crapshoot at this point. Obviously, the most important thing is, do you understand the setup? Were you okay with these two separate integrals? This one was also, I don't know, I guess relatively easy in terms of the setup. We've got the first quadrant and the second quadrant. Okay, hopefully that went well for you.